Okay, so this is the last video of chapter 3. At the end of the previous video, I gave you this question: how to calculate the median for this probability distribution. The answer, you need to calculate the cumulative distribution function first, like simply just by, calculating, summing up these numbers one by one, which is easier. And what you can do here is, first, remember the CDF, the cumulative probability, must be greater than 50%. So this 2 is the median. So of course these other guys also satisfy greater than 50%, but it will be easy to think about this. The other probability will be greater than 50% only at this point. So you can think it as the smallest, closest to 50% among the values that have CDF greater than 50%, right? So the smallest value above 50% is the median, right? So you can check the other side of the inequality pretty easily by adding 1, 2, 3, 4, these 4 numbers. Then the other side cumulation will give you also greater than 50%. Okay, this is so far it was about how to calculate the median, how to define the median, how to calculate the median. So then, let me discuss. Let me give you another interesting question. So in 1986, the UNC surveyed annual salary survey, for their graduates, class of 1984. So then, at that time, it's 30 years, 40 years ago, which major had the highest salary, average starting salary? The answer is, so among computer science, business, geography, biology, economics. Again, remember, it is 40 years ago, specifically class of 1984. At the time, which major was making most money? The answer is geography. Why? So I believe if you did not pick the other slide, the next slide, I believe most of you would not think geography as the answer, but it's because the answer is geography, whose average is $250,000. Average was $250,000 when the national average was only 22,000, more than 10 times. But why? What's going on with geography? This guy, right? So that's only because, you are right. Geography does not make much money in general, but there was one person who is exceptional. He does not need to study geography at all, but just happened to choose geography as his major, right? So because of him, geography becomes the highest earning major, right? That is the problem of the mean, right? This kind of trick, misleading results, is because you used the mean. Mean is, as I said, it's good. A lot of nice thing, widely used, very commonly used, and easy to compute. And also there are many nice mathematical properties. But one of the problems is that it is severely affected by outliers, right? By the way, just in case, I didn't say who he is. Just in case if you don't know who he is, his name is Michael Jordan. And then Wikipedia him. So I'm not going to explain who he is. By the way, so he's an outlier. It is an obvious outlier. Whatever major he chose, he would be an outlier. The problem is, he is just only one person. But one person makes the average misleading like this, right? So I don't know how much was his first salary, but clearly, obviously, it's his effect. His effect is felt clearly here. So the median, the reason why I introduced median is because it can complement the mean in the sense that it is not that sensitive to outliers. So definitely still I'm saying the mean is the first choice almost anywhere, but I'm just telling you that you have to be careful. You have to worry about you have to cautious about potential outliers. And if you suspect that there are outliers and outliers cause misleading mean, then you may need to check the median. That is what I'm saying here. So it's less sensitive to outliers. But the problem is it's not that popular and not that tractable. Like mathematically, not easy to handle. There are not many properties for median, right? Similarly, in the first example that I introduced last video was population by state. Again, from the histogram, anyone can tell that California is an outlier, huge outlier, and maybe Texas could be thought of as an outlier. So these two guys bring the mean much larger than the median, right? So here is a simple experiment. I am going to calculate the mean and the median. So going back here, I have mean and the median. Mean and median. And then I will show you the difference. Difference is calculated by the percentage, say. So now the mean is 40% greater than the median. So what I'm going to do is I will delete California. So let's see how much the difference changes. If I delete an outlier, the difference becomes 33%. So just one state, California, one state made the difference between mean and the median larger by 7% point, right? Like, let me then delete second outlier, Texas. Then the difference decreases again to 31%, right? So as you can see, a huge part of these differences between the mean and the median are because of California and Texas, right? So, and also you can check how much the mean and the median changes. Mean changes from 6.05 to 5.43, fell by nearly 10%. And then again by deleting Texas, it fell again by 0.4. But the median, of course, the median decreases because largest state is deleted, but the decrease is much smaller. Only fell by 0.25, 0.24. So it's kind of uniform. From these kind of experiment, you can easily see that the median is more stable. And mean is more sensitive to outliers. And so if you happen to have a huge outlier, you may have a misleading decision. And for example, another example is suppose that by mistake you put another zero, then how about doing this? For example, in a state like Arkansas, I entered another zero here. And then the difference increases because this state becomes an outlier, right? Or in an extreme case, I happen to write 8 instead of 3. So I confused 3 with 8. Then the difference becomes much larger. So you can understand that this difference is basically the difference between the mean and the median are basically the how big the outliers are, right? So that's the idea. And okay, then in general, by comparing the mean and the median, we can expect the shape of the distribution, right? So when you have this kind of shape, then we say the left tail is long, and in that case, these are outliers. We have outliers on the left tail, and then mean is smaller than the median because the outliers on the smaller side, they are extremely small observations, and they will drag down the mean, rather like more than the median. Like symmetrically, this is the case we just had. So California and Texas are on the right side tail. Right tail is long, and there are outliers. So in this case, the mean is greater than the median, right? As the tail is longer, the difference will be larger. Okay, so these are the outliers. The effect of outliers can contaminate the results. And this is particularly important in economics, right? In general, outliers are rare in natural science. Like for example, if you look around, let's say think about the distribution of height, distribution of weight, right? So I've never seen maybe there is no person who is twice taller than me, right? That cannot exist. Such a person cannot exist. Or so when you think about manufacturing product, you cannot find like a product which is twice larger than it should be, right? Like for example, so these kind of like say for example, when you make a paper like this, there may be an error. Like say this length may have random errors in the manufacturing process, but it cannot be like twice larger. That kind of error does not happen in reality, but they exist in economics. Like I have never seen a person who is like twice taller than me, but there are people I know. I know that there are some people who are 1,000 times wealthier than me, 1,000 times richer than me exist. Right? Maybe million times, million times, yeah, million times richer than me exist. So they are extreme outliers, and that's more common in economics, like super rich or tech giant firms like Apple, Microsoft, Amazon, Google. These kind of firms are not just average firms. So once you include them in your analysis, all the results may be just driven by one or two firms. Or stock market crashes. Usually stock market moves between, like say 0 to 10%. But when it crashes, it literally crashes. So these are extreme outliers case. Like so you have to be more careful when you handle economic data because there can be outliers. So as a result, I recommend you to think about the median when you are concerned about outliers affecting your result. Another example here. So we think about like the average like GDP growth rate or average like real wage growth rate, but those are average. So on average, how much your income increases or your wage increases. Okay, that's important. That is an important measure to see the growth. But the problem, you understand that, like everyone says, the economy is growing well, but it seems like your life does not change that much. That may not be just your feeling. That could be truth. Because when you compare the average growth and the median growth is this line, blue dots, and the orange line is average growth. So the gap is larger and becomes larger and larger. That's because maybe the growth is maybe concentrated on a few super rich people, super rich firms. So it's about inequality. So median does not grow that much, but because there are more outliers, and outliers become even more outlying. So as a result, they drag up the median, the mean, but while the median does not change that much. That's kind of real in economic data. So it's a big problem in economic data. So I give you a word of warning. Average can be misleading. Okay, then finally, okay, so this will wrap up discussion about median. In the last minute, I'm going to generalize the measure of central location. So far, mean and median, we learned mean and median as measures of central location, as a measure of central tendency. But we may generalize that idea not just for the center, like from central location to other non-central measures. So idea is simple, using the median. So median, so this is simulated data. Median is a number that divides the sample into half and half. So median captures the center, right? Then suppose that I'm not interested in the center, but I'm interested in, say, the top or the bottom, depending on your research question. So for example, I like to study the poverty. Then median is not my concern, but my concern is the lower side, those who are poor, extreme outliers among the poverty. Or I'm interested in, big tech or like leading firms. Then I'm not just considering on average or median firms, but I'd like to study, Amazon, Google, Microsoft, Apple. These guys are like on the right tail, outliers. So not the center. Center is not everything. So I'm going to generalize this idea like this. Not just don't divide the sample into half and half, but why don't we just divide it to our custom ratio, like 25 to 75 or 75 to 25. So if you cut it as 25 to 75, the point becomes, we call the point as 25 percentile. So 25% from the bottom. Similarly, you can think about 75 percentile, which is top 25%. So it's more upper side, more richer people. But as I said, it doesn't need to be 25 or 75. You can think about 1 percentile, 99 percentile, or like 60 percentile, whatever. You can choose your custom numbers and calculate the percentile, which is a measure of relative standing. So relative to the whole distribution, what is the, like say, top 10% or top 25% or bottom 10%. So it's a more relative thing. Right here, okay, so here are some common measures of relative standing. So percentile, in terms of percentiles, you can interpret 0 percentile as the minimum, right, lowest one, and 100 percentile as the maximum, okay, and 50 percentile is the median, exactly, divide by 50 and 50. And if you divide sample into 4 parts, then we call them quartile. So 25, 50, 75 are 3 cutting points, and then we call them first quartile, second quartile, third quartile. So also there are many different names like decile, like there are other names, quantile. So basically the idea is we divide the sample and choose some point where the probability below that is certain percentage. So it's like this. Probability that a random variable is smaller than or equal to a certain percentile is exactly that percentage. So that is the definition, which is also commonly used in many practices. For example, value at risk in finance is just percentile. Like, for example, I'm interested in the probability of losing 10%, or let's say, so there are 100 scenarios, But the worst 5 scenario, in the worst 5 scenarios, I will lose 10% from my stock. So then we say 5% value at risk is actually minus 10%, right? So worst 5% is minus 10%. And infront growth chart. So when I say a 2-year-old boy is 25 pounds, then even though I raise the boy, I don't know if this guy is heavier side or lighter side. It's not informative because I have no idea the distribution of 2-year-old boys. But instead, if I tell you he's at 25 percentile, then it has a better idea. Oh, okay, he's a little bit smaller than the median, but not much, 25%, right? Another thing here is like say income inequality is often represented by 20/80 ratio. So this is the difference between the bottom 20% and top 20%. So it measures the it measures the difference between two relative rankings, standings, right? And finally, you must be familiar with this standardized score. Say I got, say for example, a certain test score, but I don't know if I did well or bad because it depends on the difficulty of the test. So a better way to understand your performance is the percentile score. So relative to other exam takers, did I do well or not? If your percentile is low, that means you are on the poor side. If your percentile is like 99%, then you are top 1%. Okay. So to wrap up, so in chapter 3, we learned measures of location. So usually, like most of the chapter was about measure of central location, but later, briefly, we talked about measure of non-central locations, percentiles. And for measure of central locations, we learned mean, which is most important measure, maybe most useful measure you are going to use, you are going to learn in statistics. But also I told you it could be misleading because of outliers. So then a median could be a nice alternative. Okay, this is it. In the next chapter, we are going to continue and we will utilize those like measures and extend them for different purpose. So we'll see you in the next week. Bye.